So let's recap just a little bit. So we're talking about area as an axiomatic system, and our axiom was the square. We assumed that it was sides squared. Okay, then we were able to use that to come up with the area formula for a rectangle as base times height, and then we were able to rectify a parallelogram to show that it's also base times height. So essentially now we have three area formula that we can use to prove these other three. We basically have one axiom and then two theorems that are right there, the rectangle and the parallelogram. The next one in line is going to be a triangle. And I have three options. Can I turn it into a square? Can I turn it into a rectangle? Or can I turn it into a parallelogram? So let's go back to Geogebra and give this a try. Let's see what we can come up with. So back on Geogebra, either on the web or in the app. If you have one already open and it's got a whole bunch of stuff in it, you can click that hamburger menu button over there and then just choose clear all. And then you probably want more menu items over here, so let's hit more. Okay, so a triangle has three sides, right? So I'm going to use my segment tool in the basic tools menu, and you just click and drag your three sides of your triangle. So I'm going to click and drag in order to make side AB. If I click on point A, it'll hook it in there, and I can drag it up top here to make AC, and then connect B and C together. You can just tap those 2 points, or you can click and drag, and then it'll hook in there. All right, and then let's go ahead and, as we usually do, click on that purple circle with a white arrow inside of it for the move tool, or the button that says move, and so I can move my triangle around. Okay, so nothing terribly special about that. Oh, you know what? I need height in here, right? Because a triangle has a height in it. So, and remember, height's supposed to be perpendicular. So in that last construction, we were able to make a perfect height a perpendicular line using the construct menu. So if I scroll down, I've got basic tools, I've got edit, I've got construct. Perpendicular lines is the second one. I want to select it. And remember that you select two things. You select a point for your perpendicular line to go through. That's going to be point C. And then I select a line for my perpendicular line to be perpendicular to, which is the bottom here, AB. So click it. And I'll trace over that line with a line segment so I don't see the whole entire line using the segment tool. So go ahead and select your segment tool, click on point C, and then click on the point of intersection down here on line AB. And again, it overlaps the line, so it didn't look like it did anything, not until I hide it. So if let's see, I am going to click the Show Hide button underneath the Edit menu, and I will tap on or click on the big old line, the perpendicular lines, until it's grayed out, and then click the Move tool again, and then I can move the thing around. And we've already discussed this. We took a poll, we looked it up on the internet. The official color of a height is supposed to be red, so let's color that thing red. Boop. I just selected it. I picked the paint tool and then, chose red. There we go. Now we got it. And again, if I move point C so that it's an obtuse triangle, you can see that height disappears just because of the way we constructed it. But for this particular activity, this will work. Okay. So then some things that I might try to do, let's say, like if I did have a right triangle, like this, it looks like I could very easily turn this thing into a rectangle. So maybe I give that a try, right? Let's see if we can turn it into a rectangle by just basically reflecting this right triangle over the line BC. Before I do though, shouldn't I color this thing in? Yeah, I should color it in like I did before with the polygon tool. So I go back to the basic tools up top and choose the polygon one. And then you click all of your points in order, like so. Boom, boom, ba-doop. There we go. And remember, you have to click A twice. So you start with A, and then you end with A to close the thing off. Click the Move tool, and now it's beautiful. It's this nice, delicate pastel shade of blue. Okay. So we thought, well, what if this thing was a right triangle then? Can't I just reflect this across, reflect the blue triangle across line BC to make this thing? I don't know. Let's give it a try. Okay, so under the transform menu, you need to scroll all the way down to the bottom on your menu bar, And this time we want to choose reflect about a line. So under the transform menu, you can see that we have translate by a vector, rotate around a point, and then the last one, the third one, is reflect about a line. So select that one. To reflect about a line, you need two things selected. Whatever it is that you're going to reflect, which is our blue triangle, and whatever line you're going to reflect across, which is going to be the segment BC. So I click on that one. Oh man, that is not what I was expecting. This sort of looks like a kite. So if I click on my arrow, my move tool, and I try to move this thing, oh, that was unhelpful, right? That was unhelpful. Okay, so I am going to dial this back. Up top in this top left-hand corner, you can see an undo arrow. So let's just go backwards and get rid of that thing, because that didn't work out. It didn't work out at all. And maybe because what I was supposed to do is not reflect it over, maybe I'm supposed to, like, if I look at how this is arranged, I think I need to rotate it around that point. I need to rotate it around, right? So let me come back over here to Notability so I can kind of draw something here. So if I have my shape, my triangle, and I want this piece over there, I saw that just reflecting it oriented it incorrectly. So instead, I'm going to rotate, I'm going to rotate it around a particular point, and it's the point that is going to be right in the middle. There's a special name for that. It's a midpoint. So if I rotate this shape around that midpoint, I think I'm going to have a shape that I can work with. Let's try that. So in order to do that, I need to construct the center of this line segment BC, which is called the midpoint. I believe that is under the construct menu, and it's the very first one. It says midpoint or center. So you tap on or click on that tool and just click on line segment BC, and wow, look at there. Up pops the point E, which looks like it's right in the middle. If I click the move tool and click point C, notice that no matter where I move this thing, it stays right there in the middle. Okay, so now this time what I'm going to try to do is rotate my shape around this point. When I do a rotation, I need two pieces. Actually, I need three pieces of information. What am I going to rotate? What point am I going to rotate it around? And then how many degrees am I going to rotate it? If I look all the way back down at the bottom again to the transform menu, you can see rotate around a point. It's the second one. Okay, so I'm going to select my blue triangle. Select point E, that center point that's right there, to rotate this around. And then it automatically pops up a menu saying, hey, how many degrees do you want to rotate this around? So we want, think about it. I got to rotate it around. It's not a full turn, it's like a half turn, which is 180 degrees. And then click OK. Well, would you look at that? First of all, I think it's the wrong color. So I'm going to click on the move tool, and then I'm going to choose, let's go with green this time. I think that'll be nice. All right, and if I did move this so it's a right triangle, I can see that it does make a rectangle. But that's not true in general. My shape may not be a right triangle. Not every single triangle is a right triangle. So if I move it to some kind of generic triangle, what shape does the whole entire thing make? I believe that is a parallelogram. So let's come back and right on the screen a little bit, and you can see the shape that's happening right here on this diagram. The area formula for a triangle is actually based on a parallelogram. So what I do is I double up my shape. I have this, I started with the blue one. I rotated it basically around this point in order to generate the one that's in red. And now the whole entire shape is supposed to be a parallelogram. And we already proved that the area of the parallelogram is base times height. So do we have a base and a height for this, this parallelogram? And we do, because the base is labeled as B, and the height, you can see, is already labeled as H. In our GeoGebra, we actually put a little height in right there, right? So it's still base times height. But that's the whole thing. This piece doesn't actually exist. This red triangle, this red perimeter triangle that's right there, it shouldn't be there. So I got to get rid of it. To get rid of it, I'm going to divide this area by 2 in order to get just the area of the triangle, the original blue triangle. And so there is the reason why the area formula for a triangle is base times height divided by 2, or 1/2 base times height.